Mr. Sutton here, bringing you the Algebra 2 Chapter 7 Quiz Review Solutions on Rational Functions. For this problem, they want us to graph this transformation of the f of x function, which is the rational function here. So first, let's take a look at what's happening based off of what we see here. We notice that there is a minus 1 in the numerator. That minus is giving us a vertical reflection. The plus 1 in the denominator gives us a shift of 1 to the left, because this is inside the function, so it's opposite of what it looks like. And the minus 3 outside the fraction is giving us a shift of down 3. So we've got vertical reflection and translation left 1 and down 3. So let's do our parent table, which has -1, -1, and 1, 1. And now for the g function, to change these rules, since I'm going left 1, I need x minus 1. And since I am doing a vertical reflection and also going down 3, I need a negative y minus 3 for all that. So doing x minus 1, we've got -1 minus 1, which is -2. 1 minus 1 is 0. And then negative, for the y values, -1 is 1, minus 3 is -2. Then we have -1 minus 3, which is -4. Since we went left 1, our vertical asymptote that was originally x equals 0 is now getting shifted to x equals -1. And since we went down 3, the horizontal asymptote of y equals 0 is now going to be y equals -3. So putting all this on a graph, let me do my asymptotes first. We have x equals -1 right here, and y equals -3 is halfway between these grid lines of 2 and 4. Then we have our 2 points. -2, -2 is right there, and 0, -4 right there. So we have a branch in the upper left here, and then a branch in the lower right, and that's it for this one. To multiply these rational functions, it would be a good idea to first factor and cancel out everything we can. So this 3x is going to stay the way it is, but it looks like everything else might be factorable. So let's look at the upper left first. These both look like they have a common factor of a -3 and an x. If I take that out, I've got x and then a plus 4. Moving down to the lower left, this is a difference of 2 squares, so I can square root these and use a plus minus parentheses. So we have x plus the square root of 16, which is 4. And then we have x minus 4. And then in the upper right, I need two numbers that multiply to -12 and add up to -1. Let's see, 1 and 12 doesn't work, 2 and 6 is no good. 3 and 4 works if I have a +3 and a -4. All right, I factored everything I could. Now, what can I cancel? Well, it looks like these 3 x's can cancel out. And again, it's okay to cross cancel because you have multiplication. So these 3 x's would end up in the same fraction anyway if we were to multiply everything right away. Now we can also cancel out these x plus 4's that are in the same fraction. And these x minus 4's, we can cross cancel those. So when the dust settles, we still have this negative hanging out in the numerator along with the x plus 3. And there is nothing left in the denominator other than an invisible 1, so this is it. Now we do have to exclude anything that didn't end up in the denominator of our final function that would have made the original undefined, so things we canceled out. So going from left to right here, we have to say x is not equal to -4 because of this x plus 4. X can't equal 4 because of the x minus 4. And because of the 3x, we don't want x to equal 0 either, because that would also make this original function undefined. To get started on this problem where we have to divide these rational functions, we're going to same change flip, multiply by the reciprocal. So I'll keep the same fraction as is, change this to multiplication, and invert this second fraction. So now I'll have x squared minus x minus 20 in the numerator, and x squared minus 5x in the denominator. Next, just like a normal multiplication problem, let me factor everything I can. 9x can't really be factored, but everything else can. For 5x plus 20, we can take out a 5. That leaves us with an x plus 4. And in the upper right, I need two numbers that multiply to -20 and add up to -1. 1 and 20 doesn't work, 2 and 10 doesn't work, 4 and 5 is good. If we have a +4 and a minus 5. And then finally in the lower right, looks like I can take an x out of those, leaving me with an x minus 5. So what can I cancel? Well, definitely these x's. Also, these x plus 4's can be cross-canceled. And then these x minus 5's. So let's pick up what's left over here. In the numerator, we have a 9, and that's it. In the denominator, all that's left is a 5, so 9/5. That's pretty simplified. Now, for the things that we canceled, we have to exclude x equals -4 for the x plus 4, 0 for this x that we canceled out here, and also positive 5 because that would also make the original undefined, even though it doesn't mess up the simplified version. In order to add these fractions together, we have to first get a common denominator, which we don't have right now. In order to find out the least common denominator, I'm going to factor this one on the left so I can see what my factors are. So two things that multiply to 42 and add up to -13. Let me think here. 1 and 42 is no good. 2 and 21 doesn't work. 3 and 14 is not going to do it. 4 doesn't go into that. How about 6 and 7? Well, if they're both negative, that works. So we'll do x minus 6, which is already one of our denominators, so that's kind of nice, and also x minus 7. So the least common denominator then that has all the factors of the denominators, we need the x minus 6 for sure, and also this x minus 7. Taking a look now at my fractions and what each one is missing for the denominator, this left fraction is actually already complete, which is pretty nice. But the second fraction is missing the x minus 7. So I'm going to multiply by x minus 7 over itself, a fancy form of 1, a foo. Now I've got a common denominator and I can merge these things together. So I'm going to have the 7 from the fraction on the left. For the right side, I've got this 3 being distributed. So this is going to be a 3x and then minus 21. And I can also combine the 7 and the -21 to give me a minus 14. Just double checking real quick, it doesn't look like I can factor 3x minus 14 or reduce it in any other way. So this one is done. I didn't cancel out anything, so I don't need to exclude anything. So we're done. In order to solve this equation, since this is in the format with one term on each side of the equal sign, I can actually use cross multiplying on this one. So let me do 7 times 3x minus 1 on one side, and x minus 6 times the 4 on the other side. And then let's just distribute and simplify and solve this thing. So on the left side, distributing the 7, I've got 21x minus 7. On the right side, I've got 4x minus 24. And then let me get my x's on the left and constants on the right. So moving the 4x over to the left, we've got 17x. Adding the 7 over to the right side, this is going to be -17 over there. And dividing both sides by 17, we have x equals -1. Just double checking, if I plug -1 back in, that's not going to zero out any of my denominators. It's not going to make anything undefined. So that means that -1 is a good final answer. To solve this rational equation, since this is not in the format where we have only one term on each side, cross-multiplying is not going to work on this one, not unless we were to get a common denominator and merge things on the left side. A faster way of doing this would just be to find the LCD and multiply everything by that. So the LCD on this one, we have an x and an x minus 3, and that's it. So we'll just multiply that by all of our numerators here. So each of these numerators gets the LCD. And the effect of that is that because the LCD is divisible by all the denominators, we actually can cancel out all the denominators right away. So the x minus 3's are canceling here. In the second fraction, the x's cancel, and x minus 3's cancel in the last fraction. And now we can just multiply whatever's left over. So we have a 2 and an x for that first fraction. This next one, we just have a 1 being distributed to x minus 3, so that's just plus x minus 3. And then we have equals x distributed to x minus 1, so that's x squared minus 1x. This is just kind of your run-of-the-mill quadratic, hopefully, so let's get everything on one side and see if we can factor it. So we'll keep the x squared over on one side, and then we'll move everything over to join it. So we have a -x over there already, there's a 3x on the left side if we combine these. Subtracting that 3x over here gives us a negative 4x. And then this negative 3 can get added over here to be a positive 3. So factoring this thing, I'm looking for factors of 3 that add up to negative 4. Well, there's only one option here, 1 and 3. If they're both negative, it works. So we have x minus 1 and x minus 3. And then zeroing out each of these factors, we have x equals positive 1 and x equals positive 3. Now we always have to check with these rational equations to see if our answers make things undefined. If I plug 1 into the original, I'm not zeroing out any of my denominators, so 1 is okay. If I plug 3 into the original, 3 minus 3 is 0 in this denominator, so that's a deal breaker. That makes our original undefined. So that means we have to get rid of x equals 3. That's an extraneous solution, and only x equals 1 is a true answer for this.